Hi everybody, in this video we're going to go over test 2 from the fall 2022 semester. So in question number 1, we have a construction of two parallel lines, and we see that this works because this angle was copied from here to here. Now these two angles, if I highlight my parallel line, my lines that I want to show are parallel, and I highlight my transversal, this angle here is top right. This angle here is top right as well. So notice how these angles are in the same position where the line meets the transversal. That means that they're corresponding angles. So that brings us to answer choice number 2. If two lines are cut by a transversal to form congruent corresponding angles, then the lines are parallel. Definitely one way to show lines are parallel, and that's what's shown here in the construction. Question number 2 is asking us for the acute angle formed by J Street and Main Street. So that's that angle right over there. We are told that the obtuse angle that J Street forms with Brooks Road, so that one's acute, that one's obtuse, is 3 times the measure of the acute angle that J Street forms with Main Street. So this is the acute angle that J Street forms with Main Street, so I'm going to label it X. These two angles over here are on the same side of the transversal, and they're inside the parallel lines. We do know that the lines are parallel from the question. Since they are inside the lines and on the same side of the transversal, they are same side interior angles. And same side interior angles are supplementary. So we can make an equation, 3x plus x is equal to 180. 4x is equal to 180. X is equal to 45. And the question was just asking us for the x value because the angle formed by Main Street and J Street, that acute angle here, we represented as x since the other angle was 3 times as big as it. Moving on. In question number 3, we are told that WY is congruent to XZ. We need to show that WX and YZ are congruent. Well, WX is smaller than our given information WY, and YZ is smaller than our given information XZ. So since I'm going from bigger information to smaller information, I've already narrowed down that I'm going to be using the subtraction postulate. So I'm going to cross out 1 and 3. Now I'm between reflexive and transitive property with my subtraction. Let's talk about what the subtraction would look like. If I start with WY, from WY, if I take away XY, I'm left over with WX. And that leaves me over with WX. On the side, if I start with XZ, and I take away XY, I'm left over with YZ. So let's make sure our subtraction works. I'm starting with 2 congruent segments. I was told in the givens that WY and XZ are congruent to each other. Do we know that XY and XY are congruent to each other? You might be thinking, yes, they are the same thing. They're congruent to itself. XY is congruent to itself, and that's by the reflexive property. In number 4, I need to tell which lines are parallel to each other. I know that each line and the line next to it have a supplementary relationship. So I can find that 180 minus 112 is 68. Looking around, the only angle congruent to another angle I have here are the two 68-degree angles. I see that the 68-degree angle is near line L, and the 68-degree angle is really close to line P. And here's the transversal that intersects those two lines. Notice how the 68-degree angle is bottom right, where the transversal meets the line. And the 68 degrees is also bottom right, where the transversal meets the line. So these angles, since they're in the same position, are corresponding angles. And since corresponding angles are congruent, that's one of our ways that we can show that lines are parallel. So that would be line L and line P. Okay. Angle ROA right here with O at the vertex. Angle DTO right over here with T at the vertex. ABD right over here with B at the vertex. AO DT OR DB TOA with O at the vertex, ADB with D at the vertex, TOA again. So this is going to also be congruent to TOA, so I'm just going to put the same mark on it, and that's AOR. All done with that one. This one over here was in the last video, going over test number 1. So we're proving that we have a scalene triangle. I'm going to just take a second and graph. Okay, so I see I have a triangle here with 3 sides, AB, AC, and BC. Since in part A, we want to prove that ABC is a scalene triangle, we want to prove that none of the sides are congruent or equal to each other. So in order to show that sides are equal to each other, or in this case are not equal to each other, we're showing something about the side lengths. So that would be the distance formula, the distance between the points that are making up the sides. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Let me plug in. So for points A and B, 2 minus negative 2 squared plus negative 1 minus negative 4 squared. 2 minus negative 2 is 4. 4 squared is 16. Negative 1 minus negative 4. This changes to plus, which is 3. Squared is 9. And we have radical 25, which is 5. BC next. Negative 9 minus negative 1. 8 minus 2. Negative 9 minus negative 1, that changes to plus, and we have negative 8 squared is 64. 8 minus 2 is 6. Squared is 36. And we have radical 100, which is a perfect square and simplifies to 10. And then finally, AC. Negative 9 minus negative 2. Oops, I'm mixing the x and y coordinates now. Let me try that one again. 8, the x-coordinate, minus -2. -9 minus -4. All good. Okay. 8 minus -2, that's 10. 10 squared is 100. -9 minus -4 changes to plus. So that is -5 squared is 25. So we have radical 125. So for our conclusion, I can write, since none of the sides are congruent or equal, the triangle is scalene. That's it. You were trying to show whether the triangle was scalene or not. It's not. And we showed that by showing that none of the sides are the same length. That's all that goes there. Part B says to find the midpoint of each side of the triangle. And if you weren't sure, it was broken down into steps here. Find the midpoint of each side. So make sure that you are using your midpoint formula here. I just want to see the points, so I'm going to scroll up a little bit more. Okay, I guess I can't. So my midpoint formula, I'm going to write it over here, is the average of the x-coordinates, comma, the average of the y-coordinates. So for the midpoint of AB, let me get my x-coordinates, -2 and 2. And my y-coordinates are -4 and -1. Oops, I wrote over 0 because I was adding them together in my mind. It's over 2. So 0 over 2 is just 0. -4 plus -1 is -5 over 2. You could put it as a decimal. It doesn't go evenly. I'm just going to leave it as a fraction. Why do more work than I have to? That is an exact value. Fractions are just as good as decimals. Sometimes, in fact, they're better because sometimes decimals don't end, and then we can accidentally make a rounding error, but fractions are always the exact value. Okay, BC, 2 and 8 are the x-coordinates. And the y-coordinates are -1 and -9. 10 over 2 is 5. -10 over 2 is -5. And then finally, AC, -2 and 8 are the x-coordinates. And the y-coordinates are 4 and -9. -2 plus 8 is 6. Over 2 is 3. -9 plus 4 is -5. Doesn't divide evenly. I'm just going to leave it as -5 over 2. Oops, I think I messed that one up a little bit. Let me double check. My x-coordinates are -2 and 8. My y-coordinates are -9 and -4. I forgot my negatives. So that's -13 over 2. See, it's so easy to make a mistake. That's why I should use a calculator. That's why we have calculators. There we go. Okay. AB and CD intersect at point E. So here's AB, here's CD, and here's the point where they intersect. A lot of people were drawing parallel lines cut by a transversal, but you only have 2 lines here. They didn't say anything about a transversal. This would require 3 lines, right? The 2 parallel lines and the transversal. You also don't have any information about lines being parallel to each other, so you wouldn't be able to use any of your angle relationships when parallel lines are cut by a transversal. Those only hold when we do have parallel lines. So make sure that you are reading the question. I think a lot of people are just guessing and jumping to, what they think it's going to be without actually reading the question. And the question clearly says we have 2 lines A, B, and CD, and they intersect at point E. Measure of angle AEC is 5x minus 20. Measure of angle BED is x plus, I wrote on it so I can't see what it is, x plus 50. Notice how these two angles are vertical angles, so they are congruent to each other. 5x minus 20 is equal to x plus 50. A lot of people need work on solving equations. Let me get the x's in one spot, opposite operations. It's positive x, I'm going to subtract it. 4x minus 20 is equal to 50. Since this is a minus 20, I'm going to plus 20 to both sides of the equation. I have 4x is equal to 70. My last step is to divide both sides by 4. 70 divided by 4 is 17.5. Then it asked you to find CEB. So I'm just going to plug in here because these are congruent. So 17.5 plus 50. I found that this angle is 67.5. But we're looking for the one next to it. And these two angles have a supplementary relationship. They form a linear pair. They add to a straight line, a straight angle. So 180 minus 67.5 gives us this angle here, which is 112.5. Make sure you draw a picture. Make sure you read the question. Okay, we have parallel lines here, cut by a transversal. Angle A is 3x plus 12. Angle B is 2x plus 13. So there's many different ways that you could find the value of x. The way that I see it is these two angles here are vertical angles. So if this is 3x plus 12, this angle here is also 3x plus 12 because they're congruent vertical angles. Here are our parallel lines. Here's our transversal. These two angles are on the same side of the transversal inside the parallel lines. So they're same side interior angles. So I'm going to make an equation that says this angle plus this angle is equal to 180 degrees. This is not the only way that you could have figured out that the two angles given make 180 degrees together, but that's the way that I saw it. The angles are not congruent. People were just guessing that. They are supplementary. You need to know your angle relationships when parallel lines are cut by a transversal. 3x and 2x is 5x. 12 and 13 is 25. I'm going to subtract 25 from both sides. 180 minus 25 is 155. Then I'm going to divide both sides by 5. And I got my x value is 31. Now to find angle A and angle B, I could just plug in. So 3 times 31 plus 12. That is 105 for angle A. I can plug into angle B, but I know that they're supplementary, angle A and angle B. So I'm just going to do 180 minus 105, and I have 75. If you plugged in to 2x plus 13 with your x value of 31, you should get the same thing. Next up, we have the construction question. We're going to be constructing a parallel line. A lot of people, once again, did not read the question and constructed a perpendicular line. That's not what this was asking for. It clearly said a parallel line to AB that passes through point C. So I'm going to start off using my straight edge to make a transversal that goes through point C. It doesn't matter how you draw this transversal. It's going to intersect this line and the one that we're creating that's parallel to it. I just want to make it pass through point C. There we go. It's so hard on the computer. I would recommend making it slanted instead of like straight up or down. The reason for that is if you make your line slanted, the construction's easier. So what we're going to do is we're going to copy this angle from here to where point C is. And our goal is to create those congruent corresponding angles, like in question 1 on the test. If you go back to question 1, that is what we are trying to do here. We're trying to create congruent corresponding angles so that we can make sure that our lines are parallel. I'm going to start off with my compass on the vertex of the angle I'm copying. Going to open up any distance, it doesn't matter. And I'm going to make an arc. The arc just needs to touch the angle in 2 spots. Without changing the measurement on my compass, I'm going to go up to point C, and using the same measurement that I used for down here, I made the same arc. Notice how it hits the line in a spot. Now, since I'm copying this angle from here to here, I actually have to measure this angle. So I'm going to take my compass. Let me get a different color. And I'm going to put it on one of those intersection points. And I'm going to open up as best as I can to the other intersection point. I'm going to put an arc to show that I measured. And this measurement is the measurement of this angle, because once again, we're copying this angle and moving it somewhere else. So now, without changing the measurement, because I want that same measurement that I just measured of the angle, I'm going to move my compass up to where my first arc hit the line. And I'm going to make the same arc with the measurement of the angle that I measured. And that's it. You see where these 2 arcs meet? That's where you're going to use your straight edge and draw your parallel line right through it. It's really hard on the computer, so my line is a little slanty. You will get a better line on your paper using the handheld compass. But it is a total of 4 arcs. The first 2 arcs, the measurement doesn't matter, just use the same one. The second 2 arcs, you're using the measurement that you measured of this angle, and then you're bringing it up here. And that's it. We created congruent corresponding angles, so we know that our 2 lines are in fact parallel to each other. Okay. Number 10. Another one where people were guessing random things. So many people were just writing reflexive randomly. Remember, for reflexive postulate, you need to have something that's the same as itself. So to use the reflexive postulate, you would need something like angle 1 is congruent to itself, or line segment AB is congruent to itself. Looking through quickly, we don't have any of that here. There's nothing that says anything is congruent to itself. So reflexive postulate should not really have been a thought here. Another one, addition postulate. You're only using that if you're making your given information bigger, if you're adding things. Subtraction postulate, only if you're making your given information smaller, only if you're subtracting things. So instead of randomly guessing, what we need to do is take it step by step. Each step in our proof is going to follow from the previous step, and they're all going to come from the given information because that's the starting point. How do we know that angle 4 is congruent to angle 3 and that C is parallel to D? Well, that's right over here in our givens. We didn't just make it up. That was given to us. I was seeing so many things about angle bisectors. We don't know that. That is given to us, that angle 4 is congruent to angle 3. So we know that because it's our given information. And all of our conclusions when we write a proof are based on our given information. Remember proof uno. We always started with the givens, and we ended with what the card we were trying to prove. It's the same concept here. I'm going to mark my diagram. 4 and 3 are congruent to each other. C is parallel to D. Now it's telling us that angle 3 is congruent to angle 1, and we need to write down why. We have parallel lines cut by a transversal. I'm going to highlight the parallel lines and the transversal right next to angle 3 and angle 1. Notice how angle 3 and angle 1 are on different sides of the transversal, and they're inside the parallel lines. So they're alternate interior angles. So I'm going to write down alternate interior angles are congruent when parallel lines are cut by a transversal. That part's important because our alternate interior angle relationship, them being congruent, only holds when the lines are parallel. All of those angle relationships, except for vertical angles and supplementary angles, but the corresponding angles, alternate interior angles, same side interior angles, all of those only hold when we know that we have parallel lines cut by a transversal. I'm going to mark it in my diagram. We already had a mark on angle 3. It was purple, so I'm going to keep it purple. Angle 3 is congruent to angle 1. That's what we just showed because they're alternate interior angles. And now take a look. I see the same marks on 4 and 3 and the same marks on 1 and 3. So 1 and 4 must also be congruent to each other. And that's the transitive property. We have two angles, 4 and 1, that are both congruent to the same angle 3. Since they're both congruent to the same angle, they also must be congruent to each other. Now we need to know why angle 1 is congruent to angle 2. I took a look at angle 1 and angle 2. They come at the same point and they're opposite from each other. They're vertical angles. Vertical angles are always congruent. Finally, I see transitive property again, so let me take a look. Now everything has the same marking. So it's kind of confusing for me to figure out where I want to go from here. Luckily, I remember to keep my goal in mind. My goal is to prove that angle 4 is congruent to angle 2. And I see that angle 4 is congruent to angle 2. In my previous two steps, angle 4 and angle 2 were both congruent to the same angle 1. So that does make them congruent to each other by the transitive property. And remember, your proof always ends with what you're trying to prove. Let me get my compass back. The extra credit is just a perpendicular line through point P that was in the constructions packet. A lot of people got the extra credit, which was very nice. I'm going to put my compass on point P. Sorry, it's difficult to adjust this on the computer. And the length I open the compass to doesn't matter. I just want to intersect the line in two spots. So here are my two intersection points of my first arc with the line. I'm going to put my compass on one of those intersection points. And it doesn't matter how wide I open my compass, I'll just make it a little bit wider. And I'm going to make an arc. Using the same distance without changing the measurement, I'm going to go over to that other intersection point, and I'm going to make the same arc. Now I have where the two arcs intersect. Through there is where I'm going to use my straight edge to draw my perpendicular line. And notice how my perpendicular line is perpendicular to the original. It forms 90-degree angles with it.